Good afternoon, everybody. Welcome to the coveted "The Day is Almost Over" slot. I'm delighted that you've chosen to spend a little bit of time with me. My name is Nate Schutta. I work for Pivotal. I'm part of the advocates team. I'm an architect at heart, and so the best way to describe me is architect as a service. Someone called me that last year, and I thought, yeah, that sounds about right, because, I go places, I talk to people, and everything is as a service these days, so that fits. Although I will admit, I did sound out the acronym and realized it may not have been intended as a compliment when it was first bestowed upon me. I do apologize for my complete inability to speak French. I know just enough Spanish that my brain tries to map French to Spanish. And so by the time I leave, I'm actually starting to think in Spanish, which is really strange. In May, I was here, and then I went to Barcelona. You always have to use the lisp when you're in Barcelona. And what was so strange for me is, even though I actually do kind of know a little bit of Spanish, by the time I got to Spain, I'd been here for almost a week. And so I was trying to engage them with what little French I know, and that didn't work well. So it's unfortunate how these language things work. So let's talk about the cloud. This is where I've spent probably the last 4 or 5 years of my career. I'm sure many of you are in a similar situation. There's a lot of options here. And one of the things that I've noticed as I work with different clients, different customers, a lot of people, for better or worse, think if I'm going to the cloud, I've got to do microservices, that these two are somehow linked at the hip. And so people are very excited to figure out what this domain-driven design thing is. People are dusting off their copy of Eric's book and saying, like, I knew this would be useful someday, and we're trying to figure out what bounded contexts are, and what do we mean by a ubiquitous language, and everybody's very excited about forming, 2 pizza teams. But here's the thing. We got to remember that classic line from Jurassic Park. You were so preoccupied with whether you could, you didn't stop to think if you should. And so we're starting to see a backlash. Now, in fairness, this is repeated in technology from the beginning of time. New technology comes out, we all get very excited about it, we start using it in places where it doesn't make sense, it fails, we blame the technology, rinse, repeat. We keep looking for the magic technology, the silver bullet that will rule them all. I hate to say it, but Brooks was right, I think almost 40 years ago when he said there's no silver bullets. He's right today. He's going to be right in another 40 years. But of course, as people go down this heavily distributed world, they start realizing, man, this is really hard to manage. There's a reason they call these Death Star architectures. Right? I think that's why the Death Star keeps blowing up in various incarnations. Did you guys see that a new trailer has been released for the last Star Wars movie? Yeah, I forwarded that to my son. I'm not sure if he's watched that yet, but that actually gave me reminded me that I need to get tickets. So I texted my wife and said, please book us tickets. So apparently that's happened. Who could have possibly predicted this? Now, there's a lot of really good reasons to do microservices, but in our industry, there's no such thing as a free lunch. There are trade-offs to every technology decision we make. And so when we're going to go down this path, we have to take a step back and ask ourselves, are we getting benefit from the added complexity? Right? Is this actually making things better for us? Or have I now made things harder than they need to be? Our domains are challenging enough. We don't need to handicap ourselves by using architectural choices that are wrong. So one of the mantras that I've had, one of my soapboxes over the last several years has been, when should you use microservices? And so this actually started with client work. I was locked in a windowless conference room with my good friend Matt Stein for several days. And after I think about a day and a half, Matt finally wrote these principles up on the board. And then I went ahead and mentioned that to one of our marketing editor people, and he said, ooh, that'd make a great blog post, please write it up. And so I did, and then he said, that was great, write more. I went, that's not what I signed up for, but I did. And so I wrote what I sort of colloquially would call, please microservice responsibly. I think the way my editor titled it was, should that be a microservice? But it's the principles that we've used. Now, I want to stress, it's not the only reasons you should use microservices, but they're kind of the main drivers that push us down this particular path. Now, I won't have time to go through all of them today. I'll leave that as an exercise to you to track down the ones I didn't cover, but we'll wander through that here this afternoon. So one of the first things we look at is multiple rates of change. So inevitably, some parts of your system change all the time, and others, quite frankly, have not changed since that initial commit. So if you find yourself in a situation where different parts of your system are evolving at radically different speeds, microservices might help you. So I put together one of these prototypical little shopping sites that we've all dealt with at some point or another in our career. Looks a little something like this. These are probably our major components. recommendation engine, search, etc. There's a pretty good chance that cart hasn't really changed all that much, like add items to cart, remove items from cart, maybe we plug in a different tax module or something, but by and large, cart's pretty simple, and our inventory system probably ties into some third-party warehousing thing that we don't have any control over anyway. But our customers always want the recommendation engine to get better. I don't know if you guys remember how many years back when Netflix offered this, I think it was $1 million prize to anybody who could improve the recommendation engine by, I think it was just a few percentage points or 10% or something. And I've yet to have a customer say, you know what, search is too good. Could you please make it suck a little bit because people are just finding everything they want too easily. Now, if we're in a monolith, everything's got to move at the same rate. I think this is a fundamental reason why we've traditionally had this quarterly release cycle, because we wanted to wait until all the changes are ready because it was very painful. Now, I always thought this was kind of funny because if you think about your experience with the monolith and a quarterly release cycle, every one of you at some point in your career has been locked in a windowless room at 3 in the morning trying to figure out which of the 7,892 changes that went into this quarterly release caused us to blow up. And it's hard. Now here's the irony. If I did one change and I push that to production and it blows up, I think I might know which change caused the problem. A lot easier to back into a root cause analysis there. But since we had to push the whole monolith anyway, we might as well wait. We have options today. I can actually split things apart so the things that need to move faster can move faster. So I might decide to re-architect this and pull that recommendation engine out and pull that search bit out as microservices. So now I can deliver business value more quickly. That's always a win. Gives us some credibility, makes our customers happy. This is good. This is one of those win-win situations. But that puts us into that interesting scenario of, well, how do I know which parts of my systems need that and which don't? Well, trust your gut instincts. All right, you've probably already got an idea of what is or isn't moving quickly in your system. So take advantage of that. But data is your friend. So start with your source code management tool. That's no longer controversial, right? Everybody's using some form of source code management. You're probably using Git. Perhaps you're using Git. Maybe you're using Git. I remember very early on in my career, I was working with a friend of mine. He said, hey, can you help me with this bug? I'm like, sure, no problem. Send me a link to your repo. I'll take a look at your code. And he said, what do you mean? I said, well, a link to your Subversion repository. Send me a link and I'll look at your code. He said, oh, no, we're not using Subversion. I said, really? Are you guys still on ClearCase? He said, no, we're not using that either. And I'm like, well, what are you using? And he said, oh, we just keep a folder out on the LAN. And we duplicate it every so often. And then we email each other files. And that's when I started backing away, saying, you're on your own. I'm sorry, I can't help you. So I can use Git to actually get essentially a heat map of my history, and I can run a script something like this, which will essentially give me my top 10 list. I ran that against Spring just because I had easy access to it. Now, obviously, this is not a monolith, but, haha, teaching. Unsurprisingly, the changelog changes a lot. No one could have predicted this. Now, I don't know Spring well enough to know just how interesting some of these pieces are, but it at least gives us a place to start that, is it okay that the web MVC configuration support changes a lot? Is it okay that this parser changes a lot? I mean, it probably is. It used to be a great question to run by one of the Spring experts. So at a minimum, this gives me a place to start. And now I can roll up my sleeves, get my hands dirty, and I can practice what we all do, which is software archaeology. We can root around in the code base looking for, paraphrasing Sir Isaac Newton, smoother pebbles and prettier shells. If you've ever done a big bang refactoring kind of effort at some point in your career, you've probably had that wonderful experience. You need to replace the old system, and so you ask, what does the old system do? And they just sort of shrug and say, we don't know. But the new system needs to work just like the old system, only better. That's what I mean by software archaeology. That's a huge part of what we do in this business. Now, Michael Feathers calls this churn. And so Michael wrote about this in terms of what should we refactor. Now, unsurprisingly, as is the case in so many parts of our world, there'll be this long tail view of it. You're going to have some files that there's like people are fighting over them because we both want to get in there and modify them at the same time. And others, like nobody's even looked at that since that initial commit happened. Now, Chad Fowler took this idea and created Turbulence, where he put churn versus complexity to come up with, again, targets for refactoring. So we can use the same kind of logic here. Now, there are various code forensic tools that we can leverage as well. Now, I have not used these in Anger, but I did run across this when I was doing some research. I thought it was kind of interesting. Again, I'm not trying to push this. If you don't like it, that's fine. I just thought it gave us kind of an interesting view into software systems. And so I did this against Docker just because that was one of their demos. And heat maps start to show up, and you start to dig in deeper, and you start to say, oh, okay, red's bad. What's going on in that particular area? And you see, all right, well, this is fairly complex. There's a lot of stuff going on in here. There's been a fair amount of defects. It's clearly being touched a lot. You know, it's fairly small, though. That's good. There's only 800-ish lines of code, so that seems about right. We see this trend over time. It gets complex, and then some refactoring work happens, and the complexity creeps up, and we do some refactoring. That's not terribly unexpected in something that's changing a lot. It'll peer into the files and give us some metrics like cyclomatic complexity. That's basically how many paths do you have through your code base. That's one of my favorite things to run against code. You want that to be a small single-digit number. I've had some people argue if you've gotten above 2, you've made a mistake. You know, like 1 is a good thing to strive for. You know, now the largest that I've ever seen in Anger on code I had to maintain was 82. I still to this day have no idea how some developer sat down and created a function who had a cyclomatic complexity of 82. That's nuts. We can get some interesting sort of trends as, you know, lines of code goes up, it gets more complicated. That's not too surprising. You know, comment seems to stay fairly, you know, static. I guess this is one of those self-documenting code bases. You know, and then we get some ideas. There's other possible problem children we might want to look at. It also gives us an interesting view into who's working on what. This can help us find those single-person dependencies, you know, or as you might want to call it like a low bus number, or if you're more positive, a low lottery number. What happens if this person wins the lottery tomorrow? I worked at one company where developers had essentially dug little foxholes in the code base, and I understood why after I'd been there for a while, because they had this real history of like hiring a bunch of people and then firing a bunch of people, then hiring a bunch of people and firing a bunch of people. And so some developers decided, I know how to game this system. I'm the only one who knows what goes on back here. You can't get rid of me. Now, I didn't realize just how endemic that was in that code base until I was in a meeting one day and we were talking about some defect, and one of the developers just paused and said, oh no, only Jeff goes into that part of the code base. It is strong with the dark side of the force. And I thought, well, that's not a great place to be. You know, now the ironic thing to me about single people dependencies, some developers are like, ooh, I like that because you can't get rid of me. Here's the reality. Try going on holiday when you're the single person dependency. That doesn't work out so great. Your manager's like, well, before you leave, you're taking your laptop, right? And there's at least 3 ways I can get a hold of you, and you're going to be checking in every morning because if something goes wrong, we need to get a hold of you. But we start to see as we peer into this code base, there are some chunks that have only been really touched by one person, or one person is responsible for an awful lot of the commits. That might give us pause. That might give us some insight that we need to get some cross-pollination in there, maybe get some other eyeballs on that, do some more code reviews, pair programming, something to make sure other people know what's happening there. Now again, I'm not trying to push any specific tool. If it works for you, great. If it doesn't, great. Your source code management tool gives you a lot of data. I mean, if you look at something like GitHub, you can see, hey, when was my last commit on this file? That's a nice thing to look at very easily. You know, so if I haven't touched this since the last time we had one of those super blue blood moon Eclipse things, that's probably not a good candidate for microservices. But if I got something that's always changing, well, let's dig deeper. Let's figure out what's going on in there. Now, bugs also have a tendency to congregate in these areas. So look for your defect density. Talk to your business analysts. Where do they keep asking you to make changes? Look at your, however you're storing your requirements. Where do we keep going back for more? Now that will give you some good candidates, but what do you do now? Well, this is where we leverage the Strangler pattern. So this has been around a long time. This is something that Martin first coined, and the inspiration was a trip to, I believe it was Australia, where he saw this vine that was basically like eating a tree from the outside in, and said, that's a good metaphor for software. Not entirely sure what that says about our chosen occupation. But it turns out it makes a lot of sense, and he coined this into this idea of the Strangler Application, which says, in a nutshell, build the new around the edges of the old and gradually replace the heritage bits, which significantly reduces the risk on one of these big bang replacements. I've been on several of those projects. They're kind of painful because, again, we have that we don't know what the requirements are problem. But then we spend about 8 or 9 months telling our customers, oh, yeah, we're about 80% done. they keep asking, well, when am I going to get the other 20%? And they're like, oh, just any year now, don't worry. We'll let you know. The downside here is we spend an awful long time kind of pushing back on our customers, just leave us alone, just give us a little more time. And they don't see what we're doing. Whereas if I use the Strangler application, I can incrementally deliver business value. I can show them what we're doing on a regular basis. We can get that released into production. We can show regular progress. That's a huge win for us. Credibility is our currency. Now, I can go a step further, and I can apply data to this problem. Because again, what does the old system do? There's a pretty good chance no one actually knows. There's been so many patches, so many bugs, so many other things that have been jammed into the system. Yeah, we know what the original requirements might have been, but we don't know all the edge cases that were exposed as we moved along over 5, 10, 15 years of production. How do we know what all these little nuance is? And then as I start to do this replacement, I get all sorts of new bugs. Actually, in many cases, I'm re-implementing old bugs because I didn't know that edge case existed. So what if I had real-world data instead? And that's where this concept of data-driven Strangler comes from. So this was a Spring 1 presentation, I think 3 years ago, if memory serves. And so the basic idea here is, well, let's take that same pattern, but let's put a proxy in between the client and the legacy system. Now that proxy's first job is fairly straightforward. Log inputs and outputs. You give me 2, I give you 4. You give me B, I give you D. And if you run that long enough, you now know what the old system does, at least in most situations. I can use that as a great basis to come up with my test cases, because I have yet to find legacy systems that have a rich, robust test suite around them. So it looks a little something like this, not too surprising. And once we understand what the old system does and we start to re-implement that functionality in the new module, we actually can run them in parallel and make sure we didn't screw something up, make sure we didn't miss some weird, interesting edge case. And so for a period of time, however long I need to go to feel comfortable, I can route requests to both and then compare the results that come back. If they match, awesome, life is good. If they don't, you're probably going to want to default to the heritage response, but you best log that out and have a human being investigate. There's a pretty decent chance that in a lot of situations, the old system was wrong and nobody knew it. I'll give you my favorite example of this from my own life. Years ago, I had this somewhat interesting flight itinerary where I needed to go from my home airport, MSP, to London, to Chicago, back to MSP. And so my travel person first priced out and said, wow, Nate, this is going to be like $3,000 US. I'm like, oof, that's a little more than I wanted to spend on this. And he said, well, let me play around a little bit. I've long since learned that a huge part of what travel agents do is try to game out the pricing algorithms at various legacy carriers like Delta, American, et cetera. And so he came back and said, I found a way to cut the price in half, but one of the flights has to be a one-way. And I said, oh, so that means like if I miss my connection, Delta can just laugh at me? And he said, no, actually, it's still going to be that same itinerary. It's just you're going to have a one trip that's Minneapolis to London to Chicago, and then a one-way from Chicago to Minneapolis, and that's going to cut the price in half. Now, that made me very happy. I guarantee that there's some COBOL programmer at Delta who can explain why that happened. And there's also some VP of business something who was very unhappy that happened, because the same seats on the same aircraft were half the price because one of the legs was a one-way. I have no explanation for that other than thank you, Phil, for trying that. So the next thing we want to look at is independent life cycles. So I've been in a lot of enterprises most of my career, and I always hear we're a big ship, we don't turn on a dime. And you know, I remember when I first got into industry, it's perfectly acceptable to say that project would take 18 months. That doesn't work today. The world we live in today has got to constantly change. We need to be able to run experiments. We need to be able to do A/B tests. We need to be much more responsive to the changes that are happening in our business environment. We need to turn things around in days or weeks, not months or years. So at Spring 1 a couple years back, a gentleman from Scotiabank got up and talked about their journey from the typical quarterly releases to thousands of releases a month. And I remember talking to some of my former colleagues, good friends of mine that were there from my previous organization. They said, oh, Nate, you know we'll never be able to do this. I said, why not? If a bank can make this shift, if a nearly 100-year-old bank can make that shift, why can't you? I mean, there are very few industries that are as heavily regulated as financial services, for good reasons, obviously. But if a bank can make this change, we can all make this change. Because whether we like it or not, speed matters today. Disruption is impacting every business. No one is immune from this. So if we go back to our widget.io monolith, what if our business partners come up with this exciting new opportunity, but we need to be able to turn this thing around right away? They can't wait for the quarterly release cycle. Well, if we split that off as its own thing, it can go ahead and move at whatever rate it needs to. It can have its own repository. It can have its own build pipeline. It can have its own independent lifecycle. Now, obviously, speed to market's a huge win here. But let's not neglect improved developer productivity. If you've ever worked on a monolith, you had that wonderful experience shortly after you joined the team where somebody dropped this dictionary-sized getting started guide on top of your head. And as you dutifully work your way through it, there's always a section that says, now talk to Kathy. And then one person has to come over and finish setting something up because there's some alchemy that only they know how to produce. I was that person on a project for a while. I was on the project in the beginning, and so I got embedded in their getting started guide. And then I left the project, and with it went my rights to update the getting started guide. And for like 3 years, I'd get these random phone calls from developers and be like, hey, I just joined the Wombat app. It says I'm supposed to call you to finish my ID. I'm like, okay, fine. And it wasn't until a buddy of mine finally rolled on the team and he said, why am I calling you? I said, because I was there in the beginning. He said, okay, do you want me to update it? I'm like, yes, please. And then I finally got out of the business of having to help everyone set up their ID on a project I hadn't been involved with for many years. I was at one company where our build literally took 24 hours or more to complete. Ponder that for a minute. You check in code on Tuesday and you find out on Thursday or Friday that you broke the build from the thing you did on Tuesday. What was I doing on Tuesday? I don't remember. That was so far in the past, I can't even recall. And did we even exist on Tuesday? I don't know. You think about how long it takes for someone to get up to speed. That same company, sort of the general expectation was it would take you a year to be productive on that code base. You know, think about what your longest stretch was as on either side of the coin. New person joined or you were the new person. So if I have a smaller scope, if I've only got 10,000 lines of code, I can get my head wrapped around that much more quickly. Builds can finish in a minute or two. Build breaks are fixed promptly because we find out about them shortly after checking in the code, not days later. It can be much easier to test. I was on one project and I made a suggestion and my QA lead just glared at me and I said, you have some input on that. She said, yes, don't make that change. I said, why not? She said, if you make that change, I have to do an 80-hour manual regression test. I said, oh, I guess we'll have to scrap that plan then. I can have a set of fine-grained tests that run every time there's a commit. I don't have to do a performance test as this one-off that we do 6 weeks before going to production and then throw in a drawer because it's too late for us to do anything about it. I can actually adapt as I need to make changes. I can use the right tool for the job. When I'm on a shared lifecycle, I'm at the mercy of whoever my slowest moving piece is. I'm not forced into this one-size-fits-none approach. Every microservice can do what's right for that microservice. It can use the test that makes sense. It can use the appropriate linting rules, code quality rules. It can be much more easy to find fitness functions. I can actually practice hypothesis-driven development. Predictions are hard, especially if it's about the future. That's what Niels Bohr told us. How many times have you been in the project room and you've had a passionate debate? This is the solution to that problem. My approach will clearly increase conversions, increase sales, whatever it is that's magic for you. How do you know? I mean, you have to be confident. Just argue confidently. What happens if you're wrong? If I'm in a monolith and I'm moving at this quarterly release cycle, by definition, I need to be conservative. I need to take baby steps. Because if I'm wrong, I just lost 3 months. It's really hard to recover from 3 months. That's a lot of development under the proverbial bridge. With the microservice, I can actually test these things out. I can actually do A/B testing. I can actually structure things like this. I can say, we believe this change will result in this outcome. We will know we have succeeded when we see this change in this metric. So we believe adding a distributed cache will result in faster startup times. We'll know we've succeeded if startup time is less than 15 seconds. This might help us find fitness functions. Now, A/B testing is nothing new. This has long been the purview of Google and Amazon. You know, there's an apocryphal story that Google apparently tested like 47 shades of blue, which I don't know if that's actually true or not, but it, you know, makes for good reading. But that always used to be just for the tech giants. It's now there for all of us. Because let's be honest, we don't have customers that are like, oh no, it's okay if the product doesn't get better. Of course they want a constantly improving product. Now, this comes with a hitch though. In order for this to work, we have to focus on paved roads. You know, a lot of people get very excited about microservices because, oh, I can use whatever I want. I don't have constraints anymore. But here's the reality. Even at the companies with the most in-depth developer autonomy, the most ingrained developer autonomy, they still have this notion of paved paths. Here is a well-worn path. We know it works. We know how to support it. We have experience with it. If you choose to go off on that minimum maintenance road, good luck to you. You're on your own. You build it, you own it. What a lot of developers fail to realize about microservices is with that autonomy comes accountability. You are accountable for the outcomes. Oh, you want to use that esoteric database or that programming language we don't use here? Okay, cool. You're the one who's going to have that difficult conversation if it turns out you made a bad technical choice. Now, here's the other great irony of this to me. You know, again, I think quarterly releases are bad because you're grouping up a whole bunch of changes and you're shoving that out at once and then fingers crossed it all worked. Here's the other problem with quarterly releases. You don't do it enough. The only way we get better at something is repetition. This is true of everything. This is one of those conversations I've had with my son. He's 12, and he still doesn't quite understand that like expectation and effort have to line up. If you want to get good at anything, whether that's a sport or an instrument or getting software to production, and you only do it a few times a year, how good could you possibly get at it? If you're deploying dozens of times a day, you will get better at it. This is one of those rare things where if it hurts, you need to do it more often because then you will buff off the rough edges. With the quarterly release cycle, no one enjoyed that experience. We all walked out of that room after 72 hours and went, let's never do that again. Yes, let's talk about how to improve it. Well, not now, it's too soon. Too soon. Give me a week. And then a week later, we're like, oh, we're on to other things. Good, thank God, that's months in the future. I don't need to worry about that. So you will get better at this if you do it more often. That will give you trust in the process. You also need to have robust pipelines. Automation is your friend. Now, there's a ton of tools that can help you here. If you aren't sure how to build a pipeline, surprisingly, the Spring people have an opinion. So they have this opinionated build, test, stage, prod, flow. Now, I want to stress this just is a starter set. It is not a we want to own your build by any stretch of the imagination. It is a place to start. I am very much of the opinion that independent life cycles is an underappreciated benefit to microservices. The most dangerous words you can utter in an organization today is, that's how we've always done it. That just doesn't work anymore. Last year, I went in to consult with a client, and they were having issues with their overnight batch run. They weren't finishing overnight anymore. And so they walked me through their architecture, and essentially they have groups of widgets. They process each widget, you know, one after the other, and they do some aggregation. They move on to the next group, rinse, repeat. And when they first started, that was great. They only had like one group of widgets, and so it got done overnight. And then as they've been successful and they keep adding groups and groups and groups, well, it's not finishing overnight anymore. And so after they walked me through it, I asked what I thought was a pretty obvious question. Does the result of processing widget A have any effect on processing widget B? I said, what do you mean? I said, well, do you have to do them serially? Could you process them in parallel? Could you have a group of workers that just grabs the next widget off the queue, does its thing, and then puts the result somewhere else? And it was like, you know. Now, I'd like to think that I have some amount of experience and intelligence and whatnot in this space, but the reality was I had the benefit of coming in with an outside perspective. I wasn't hamstrung by, that's how we've always done it. I could ask the impertinent question. Now, obviously, one of the things that microservices give us is the ability to scale independently. If you've ever started greenfield on a monolith, you know that we had to make a whole bunch of decisions very early on, often when we knew the least. one of the most common questions we would get asked is, so how much capacity are you going to need on this fancy schmancy new application? And the only answer we could possibly give was, I have no idea. And so that's not good enough. They want real numbers, so we'd get a spreadsheet out and we'd swag something together. We'd basically take the worst case, double it, add a little more, probably double it again just in case, because it was so labor intensive to get a new instance of a server that it is better for me to over allocate and not need it than the opposite. I am convinced that every enterprise ticketing system is a game you cannot win. If you somehow manage to get a ticket through, that sends an alert to the people who own that system and they figure out how to close that loophole. I don't miss that about enterprise IT. And of course, you got to go to a bunch of meetings and you got to respond to email and you got to follow up and, beg and plead and figure out who specifically needs to do this. And of course, this meant we were always incented to over allocate because it was better to have it and not need it than need it later and have to go back and beg for more. Now, the unintended downside of this was, I have single digit resource utilization. Now, I've had some people say, I don't care about this because all my traffic is predictable. One of my architects argued with me about this a few years back. He said, the only thing we need to worry about is end of year and mid-year. I said, right, are you really sure all of your traffic is that predictable? What happens when you have unexpected demand? So yeah, I can plan for marketing or sales as a big new thing. But today, we're impacted by these social media influencers. If someone like, Dwayne Johnson tweets out about your product, you're going to see a bit of an increase in people coming to your site to buy your product. Are you ready to handle that or not? Now, as bad as this was for us, it was no easier for operations people. This annual budget cycle meant it was really hard to gradually add capacity. They always had to try to be out ahead of us. They had to predict where we were going to be. Now, luckily for us, cloud environments, microservices say, flip that script. I can add and remove capacity as necessary. I can wait to the last responsible moment instead of, I think this is what I might need, so let's triple it. Now, obviously, the monolith had this same problem. There was no way for me to scale just the parts that needed it. It was all or nothing, which meant, again, I'm almost always over allocated. So if I go back to this widget.io example, there's a pretty good chance that order processing system has unique ebbs and flows in its demand structure. It probably would benefit from me being able to add capacity and remove it as necessary. So microservices gives me the ability to fully utilize all this compute. But how do I know where my problem children are? Well, monitoring is your friend. If you are going to do microservices well, you best have your monitoring figured out. This is why so many people are talking about site reliability engineering today. This is a great book. What I love about it is you don't actually have to read it cover to cover. It is a series of essays that are roughly grouped together by themes. Read one this week, put it down. 2 weeks later, read another one. A month later, read another one. Rinse, repeat. Now, obviously, you could read it cover to cover if you wanted to, but it's not required. So one of the things they talk about in the SRE book are the 4 golden signals. So those are latency. How long does it take to service a request? What is my traffic load? What is my error rate? What is saturation on some constrained resource? We need to think long and hard about our sampling frequency here. We always had this tendency to give me the highest frequency possible. Turns out that might not give us better data. That might just cost us more and not help. So aggregate the data is generally the way to go, although this is, again, why we need good teams that know how to do this. This is not something you get right the first time out of the gate. There's a whole bunch of tools out there. Of course, you can always just use Spring Boot Actuator. Imagine that. There's a whole bunch of cool stuff baked right into Spring Boot, assuming you're using that. This is not something you're going to get right day one. This is, again, why so many companies are spinning up an SRE team or an SRE function. Be very cautious that you don't glom onto some metric just because it's easy to measure. Lines of code, anyone? Just because it's easy to measure does not mean it's useful for you. Now, one of the other challenges that we face is we need to understand the business drivers on this application and what might cause things to spike, and then how that translates back to the technology that we're writing. Now, the other part of this that's vitally important is you need to be realistic. If you've ever talked to a business person, they're a very optimistic lot. They think we're going to have, 8 trillion customers by the end of the year. It's like, stop, there aren't that many people on Earth. Are we going to let cats and dogs use this software? Which would be fascinating. I'm sorry, but we can't all be a third of internet traffic. So be realistic. So yes, independent scalability is a massive win, assuming you need it. That brings us to failure isolation. I'm sorry, no service is an island. As soon as you go down this path, to quote Obi-Wan Kenobi, you've taken your first step into a larger world. So no microservice can do its job on its own. Name implies as much. And of course, integrations are nothing new. This has been done since the beginning of time, often with baling, twine, and duct tape. That's one of my favorite scenes from Apollo 13 when they dump all that stuff on the table saying we need to make this fit into this using nothing but this. That's software right there. So you're going to rely on some third-party thing that doesn't meet your SLO. They're going to fail. Going back to Jurassic Park, failures find a way. Our customers don't care why. That's our problem. That's our fault. So I can use microservices as a way of isolating those failure cases. There's a pretty good chance you already know where the problem children might be. Don't be afraid to do an architectural review. Look for failure points. Draw the architecture up on the board. Point at something. Ask, hey, what happens if that fails? You know what I hear a lot when I do this? Oh, it can't fail. I say, just humor me. What happens if it does? Now, that's not an easy thing for us to do. We also are an optimistic lot, and it's pretty easy to think of the happy path. It's a lot harder to think of weird edge cases. We need to think through what happens when this specific thing in time occurs. I had this experience once on a project. It was one of those things where we wrote it and then handed it off to a team to actually run it. And a few months later, my director comes to me and says, hey, you worked on that project, right? I said, yeah. So, well, they had a build break this morning. Could you help them? I'm like, well, sure, of course, but they should just look at their last commit. That probably caused the build break. He says, well, that's the thing. They haven't changed the code base in a couple of days. I said, ooh, that is weird. And so I went and looked at their Jenkins box, and I realized, one of the tests failed. And I dug into it and realized, oh, this test is going to fail every 7 years. Oops. I wrote it, so it's my own fault. I don't remember how I fixed it. I may literally have just commented it saying, yes, this is going to fail every 7 years. I'm not sure. Right? So it's hard for us to see some of those weird edge cases. It's much simpler to see the happy path. We need to think about the road less traveled. We need to think about what does our service talk to? How do they talk? What are the service level objectives here? Does everyone on the team actually understand all these things? Probably not. There will be gaps in the knowledge. That's a feature, not a bug. So now that we understand the failure cases, what do we do about it? How do we react? Do we send an error message? Do we call a backup service? Do we just have a cached result? Do we have a default answer? Well, there's only one thing I can say. It depends. And that's where we embrace Mr. Nygaard's circuit breaker pattern. Looks a little something like this. Circuit breaker sits in between. It watches the calls. Once we exceed a certain failure threshold, they open the circuit, which redirects us to our predefined fallback mechanism. The circuit breaker periodically checks to see, are things working better now? If so, we go ahead and close the circuit. Now, the reality is you will not think of everything. That does not mean you're a bad engineer. That just means you're human. This is why so many people are embracing chaos engineering. I would have loved to have been in the room when they first proposed Chaos Monkey. Someone like us was sitting in a room with other people like us and said, okay, hear me out. Here's what I'm going to do. At some point in the future, I'm not going to tell you when. I'm just going to go randomly yank out some networking cables and see what happens. Everybody good? We good with that? Probably not. I'm going to go on a limb and say that was not a well-received idea at first. Now that brings us to developers' most frequently quoted reason to embrace microservices, because now I can finally justify using that esoteric language or database or framework. Thank God for microservices. Monoliths forced us to standardize. I've been in a lot of organizations where we literally described ourselves by our tech stack, as in we are a Java shop, we are a Ruby shop, we are a .NET shop, which is just another way of saying I have a big hammer, please someone bring me a problem, because I know how to solve it. Now, there are positives to this approach. If you've got 10 years on a tech stack, you're going to develop some expertise. It can be simpler to shift people for cross-pollination, to balance workloads, give people new challenges. It can make things easier in terms of hiring and training. Although I heard some great advice on hiring recently. A person said, hire smart people who are kind. I thought, yep, that's a pretty good way of simplifying this whole process. I'm honestly of the opinion the way we hire is just wrong in this industry. We get so fixated on this checklist of skills instead of worrying about, can you learn new things? Because I'm pretty confident you're going to need to learn new things in your job if you're going to be here for more than probably 3 or 4 weeks, quite frankly. Our operations people can focus on just that one environment, but let's be honest, one size does not fit all. There are downsides. Currency was almost always constrained by whoever your slowest moving app was. No, I'm sorry, you can't have nice things because the Wombat app isn't ready to migrate. I've seen plenty of instances where by the time we upgrade to the new version is end of life. That's not a lot of fun. Now, to be fair, very few organizations were ever truly just one thing. And even if they were, all it takes is a merger or an acquisition and boom, we have another tech stack. I have yet to see the company that says, hey, technology people, we're thinking about buying these people. Is that going to be a problem? By the time we get involved, it's here, make this work. Make this fit into that using nothing but this. So cloud computing removes that one constraint from us. I actually can spin up multiple stacks if I want to. Polyglot programming isn't just a pipe dream anymore. However, we need to be responsible technologists. We need to understand that these are just tools. I'm a software person, which means one hammer is more than sufficient for me to screw up any project around the house. But if you've ever gone to a big box retail store where they sell, tools, they have a whole aisle full of hammers. Different sizes, different weights, different handles, some are smooth, some have a little knurling on it, some have a little hook at the end so you can pull out the nail you inevitably bent while trying to fix something. The difference between the master craftsperson and us is the fact that they know when to pick up which tool. We need to apply that same discipline to software. Just because I really want to use Go or Kotlin or Clojure doesn't mean it's the right choice for the problem in front of me. The challenge for us is knowing when to pick up which tool. Now, the advantage of this environment is I'm not forced to take that square peg and pound it into a round hole. Now, there are downsides to this. There's always a but. We have to be very aware of technical sprawl. So yeah, it's great. Everybody can use what's right for them. But here's the thing. Every developer has their own favorites, which means there's not going to be one way of doing something. There's going to be like infinity ways of doing something. And now we got a lot of different ways of doing the same thing. How do I staff up? Talk about the challenges of a quote-unquote full-stack developer, which I could rant on for another hour, but I won't do that to you. But what do I do when I've got all these different things written in all these different languages? How many third-party libraries do I need to support all that? Can I even stay current on all that? There's another thing we have to be responsible for. These bugs are having huge ripple-out effects. They're causing people to lose their jobs. Every time I turn around, there's a new largest hack ever. I mean, at this point, we should all just assume all of our data is available on the dark web. So no, it can't be a free-for-all. We're going to need some guardrails. Some companies standardize on a platform, say you can use whatever you want as long as it runs on the JVM. My previous organization, we had 3 flavors. A big part of my job as an architect was to tell you why you were wrong if you said you needed something other than those 3. Again, this gets us back to paved roads. We know how to support this. This is a well-worn path. If you go this way, I know how it's going to work. If you go on that minimum maintenance road, good luck. Again, you build it, you own it, you're the one getting paged at 3 in the morning, not some poor operations person. We need to be very aware of the reality that sprawl exacerbates our accumulation of technical debt, which is why we need to think of these as microservices. They need to be small. Now, we can debate that until the proverbial cows come home. That's why I'm partial to anything that can be rewritten in 2 weeks or less. Because if I make a mistake, I've lost an iteration. I can recover from 2 weeks. The more time I've spent on something, the more invested I am, the less likely I am to change course, even if we should. See children. I'm convinced this is why kids survive teenagerhood. Because by then you've already got like a decade plus into them, and you remember when they were cute and cuddly. So you're like, okay, I'm going to forgive the next few years, hoping you return to being a normal human being. My child is 12. I rest my case. So yes, microservices allow us to choose the right tech for the job, and that's awesome. But I have to weigh the pros and cons. Remember Uncle Ben's wise words. With great power comes great responsibility. You build it, you own it. The biggest problem here is a lot of developers go down the path of, resume-driven design. I chose this language so I could put it on my resume. That's not the right reason to pick a technology. I'm sorry. So yes, microservices really do give us a set of impressive benefits, but they come at a price. Do not pay the complexity tax unless you get something in return. So no, not everything should be a microservice. Use them where they make sense. Use them where they add value. If you need one or more of these principles, awesome. Go build microservices. If not, don't worry, they're serverless. That's the next rat hole we're all pouring everything down. Isn't that awesome? Good luck. Thank you so much for your time and attention. I really do appreciate it. Cheers.